All right, let's take a look for a minute at some properties of parallelograms. A good place to start is what the heck is a parallelogram? So a parallelogram is just a quadrilateral, so that means it's a four-sided polygon, and its opposite sides are parallel. So it would look like this. When we say opposite sides of the figure, what I mean is if we look at this side right here, and then you travel directly across to the opposite side of the figure, that's going to be the opposite side. So in a parallelogram, both sets of opposite sides are parallel. So that side is parallel to that side, and that side is parallel to that side. Bet you can't guess where the name comes from. Now, for this to be a parallelogram, both of those have to be true. It can't just be one set of sides or the other set of sides, but rather both sets of sides have to be parallel. Now this gives rise to some other neat properties, so we'll take a look at this up here. First, opposite sides are congruent. So remember I said an opposite side are the ones that are directly across from each other. So opposite sides of a parallelogram are congruent. So I could even go so far as to mark these off, that this side and this side are going to be parallel and congruent. Those are opposite sides, and that these two sides right here are going to be congruent as well because they are on opposite sides. So opposite sides are congruent, and it turns out that this is true of opposite angles as well. Opposite angles are angles that are just directly across from each other, and so I can say that this angle right here is going to be congruent to this angle because they're directly across from each other. And then likewise, this angle up here is going to be congruent to the angle directly across from it. And so we can see we have these pairs of congruent angles in the parallelogram. Alright, next we're going to look at what are called consecutive angles. So consecutive angles are angles that are right next to each other if you're walking along the figure. I'm not sure that made much sense, so let's try it this way. Suppose we have this angle here. The consecutive angle, or the consecutive angles with this, are the angles that share one of those sides. So for instance, the vertex of this angle is the endpoint of this side. The other endpoint of that side is going to be the vertex of a consecutive angle. And these two, under most circumstances, will be different. They won't be congruent, but they will be supplementary. So that means the measure of this angle plus the measure of this angle are going to add up to 180 degrees. Notice that this angle is also going to be congruent to this one, which means this angle is going to be supplementary to both this one and this one because it's a consecutive angle with both of those. Alright, so opposite sides are congruent, opposite angles are congruent, and consecutive angles are supplementary. The next thing we're going to look at, given something like this, is called a diagonal. So we have our parallelogram. I'm going to go ahead and tell you that's a parallelogram. Diagonals are lines that connect one angle, or the vertex of one angle, to the vertex of its opposite angle. So it might look like this. That would be one of the diagonals of this parallelogram. There's a second one that we'll put in blue that looks like this. And the thing you need to know is that for parallelograms, the diagonals will bisect each other. So that means that point where they intersect right there bisects both the red one and the blue one. So we can see these two parts of the blue one will be congruent, and these two parts of the red one will be congruent as well. So we can add that to, remember I told you this was going to be essentially a list of facts about a parallelogram. So now we know opposite sides are congruent, opposite angles are congruent, consecutive angles are going to be supplementary, and now we also know that the diagonals bisect each other. Alright, the next thing we're going to look at is area. So we need to be able to calculate the area of these. Area is just the amount of space that's contained on the inside of the figure. And for any parallelogram, it doesn't matter what kind of parallelogram it is, because we'll talk about different types a little bit later, but no matter what kind of parallelogram it is, the area is always base times height. So the base would just be, pick a side, any side, whatever length you want, and the height will be a perpendicular segment from that to the very highest point on there. You might remember that this particular line here would be called an altitude if this was in a triangle. It goes from the vertex and then runs perpendicular to the side opposite of it. And that's how you need to find the height of a parallelogram. You need an altitude. So you need a distance that is perpendicular to whatever base you choose and runs to whatever highest vertex you have of that. We could do this the other way as well. If we wanted to call this the base of the triangle, all we would need is the height running, it would go this way, running perpendicular to that, and we would have our base and height, and we would just take whatever numbers are there and multiply them together to find our area.